Section 1.5, Laws of Propositional Logic. Don't panic, I'm not going to ask you to memorize every term that you see over here, but sometimes it's helpful to be aware of the most common ones because we do talk about them from time to time. So if you look at that list, there should be a few terms that are familiar to you. So for example, I'm sure you've seen associative, commutative, distributive in algebra. You probably also have seen something along the lines of identity, but you may not have seen idempotent, domination, double negation, and so on. So you don't necessarily need to remember the names of these laws, but we should more or less understand how they work. Okay, so let's do these four first so we can feel a little bit more confident about it and see what that looks like. So if you remember from algebra, when we use the term associative, it usually means something along the lines of we can move the parentheses. And that's exactly what it means right here. So if we have quantity P or Q or R, that is equivalent to saying P or quantity Q or R. And for the and statement, P and Q and R is equivalent to P and quantity Q and R. And sometimes for those, we can just leave the parentheses out altogether. We can say P or Q or R. We can also say P and Q and R, although technically and or are binary operators, so they should only happen between two things at the same time. Commutative laws usually means that we can switch the order, and that is also the case for disjunctions and conjunctions. So P or Q is equivalent to Q or P, order doesn't matter. Likewise with the and symbol, P and Q is equivalent to Q and P. Distributive laws usually has something to do with how we can distribute something that's happening on the outside to something that's happening in some parentheses. And these, if you remember what we talked about, how the or operation is very similar to the plus symbol, addition, and the and symbol is very similar to multiplication, then this is sort of how that works. So P or quantity Q and R is equivalent to P or Q and P or R. And if you don't believe that, we could fairly easily prove that just by creating an exhaustive truth table. So P and Q and R, that would be a truth table that had 8 lines, a little bit long, but not impossible. We could surely convince ourselves of that. The statement P and quantity Q or R, the distributive law works on that as quantity P and Q or quantity P and R. As far as identity works, so it's sort of like adding 0 or multiplying by 1. So P or false, P or a statement that is definitely false, is just going to leave us with whatever P happens to be. Okay, so kind of like, 5 plus 0 is still 5. Or x plus 0 is still x, whatever x is. We might not know what it is. And saying P and a true statement will leave us with just P, kind of like multiplying by 1. Okay. As for the other laws that don't really have a correspondence in algebra, let's just go through those. The idempotent laws, you don't have to necessarily remember that terminology, but P or P is equivalent to P. All right, that seems reasonable. P and P is also equivalent to P, so that doesn't really help us very much. Back down here, skipping the stuff that we've already done, P and false is necessarily going to be false. That's kind of like multiplying by 0. Saying P or true is definitely going to end up being true. I can't really think of an analogy for that one, but that's going to end up being true. Okay. Saying not P, well, what do you think that's going to be? Yep, that's going to be P. P, the complement laws, P and not P, we talked about that earlier. That's definitely going to be false. It's impossible for that to be true because you're going to have true and false. Of course, not true would be false. And P or not P is always going to be true because one of those is necessarily true. And then not false also complements to true. De Morgan's laws. So they have a special name because probably they're so important, but that is how do we distribute a negation, okay? So when we negate a disjunction, when we negate an or statement, it turns into an and statement of the negation of each of the propositions. So not quantity P or Q is equivalent to not P and not Q, while the negation of the conjunction P and Q is not P or not Q, so the disjunction of the individual negations. So that will come up. Absorption laws, we probably won't use those very often, but we might as well go ahead and answer the question. P or P and Q will end up being P, so it's kind of like the Q got absorbed, aptly named. Likewise, P and quantity P or Q is also going to be P. And then the conditional identities. This is kind of an important alternative way of interpreting the conditional identity. P implies Q is equivalent to not P or Q. So if you create a truth table for yourself, you will see that those two statements are in fact equivalent. And then as we mentioned before, the biconditional statement P if and only if Q is equivalent to P implies Q and Q implies P. And that's it for section 1.5.